we'll do what we can. All right, so this chapter 8 is about covalent bonding, which is different than chapter 7, which was ionic bonding. Ionic bonding, they were losing electrons. Our atoms or elements were losing electrons. They could lose 1, 2, or 3 electrons, or they could gain electrons. They typically were gaining 1, 2, or 3 electrons, all right? Again, the ionic bonds were losing electrons, gaining them. They were positive ions. They were cations. They were negative anions, all right? They are trying to get a noble or electron configuration that was similar to a noble gas. Covalent bonding doesn't lose electrons, doesn't gain electrons. They share electrons. They're being nice, okay? Sometimes it can be kind of a tug of war situation, which I think I'll put in the notes from on Friday, so I won't go into that. But they are sharing the electrons between them. Covalent bonds are between non-metals only, so there's only a small handful that it's going to be. Ionic bonds are between metals and non-metals. So at the very beginning of the notes, I was talking about the difference between a structural formula and an electron dot diagram, and we kind of looked at electron dot diagram. Hang on one second. We kind of looked at an electron dot diagram in, yeah, I want to share that. Chapter 7. I have my pen out. And the electron dot diagram is basically what they look like based off of how many valence electrons they're in, okay? And we're only, especially with these covalent bonds, we're only going to deal with the elements that are in the representative group. So that would be like 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. We're missing all the transition metals, so we're not going to do those. So group 1 was metals. They all had 1 valence electron. Hydrogen is the only non-metal in that group, but it would have 1 little dot to represent its 1 valence electron. Group 2 would have 2 valence electrons, but there are no non-metals there, so I would skip that. Group 3 has a metalloid and then a bunch of metals. They would have 3 valence electrons. I'm going to skip that. So starting with group 4, we have carbon is the next non-metal, and it would have 4 valence electrons. Then there's nitrogen and phosphorus in group 5A. Nitrogen and phosphorus would both have 5 valence electrons. Oxygen is in group 6, oxygen, and then sulfur is in group 6A. Oh, I'll put sulfur first. Whoops, whatever. There really is no rhyme or reason where you're going to put the dots as long as you got 6. And then 7A, we're going to have fluorine, chlorine, bromine, iodine. We're going to have several. I'm just going to do fluorine, but they're all going to look like fluorines. They're all going to have the 7 valence electrons. Group 8A, all of them have 8, but they can't gain any, okay? So what we're going to be doing today is basically kind of like doing like a puzzle piece where we can see I have, and hydrogen's not going to gain but 1, all right? It only needs 1 extra electron, so we're going to make it, it's kind of the main puzzle. The rest of these are trying to get 8, so they're trying to get to the noble gases, where they have 8 dots all the way around. So we can see, you know, carbon has a blank here, carbon has a blank here, carbon has a blank here, and here. So these are like its open spaces that it can take an electron. Nitrogen has 3 blanks. Same with phosphorus. Sulfur has 2 blanks. You know, and fluorine, chlorine, bromine all would have 1 blank. So that's why this is a -1 charge if we're doing ionic, why this is a -2 charge, why this is a -3 charge, okay? Carbon is weird and really doesn't lose electrons or gain electrons because it's literally right in the middle. So it's a sharer. It's only going to do covalent bonds. It's really not going to do ionic bonds. That's why we don't include carbon when we talk about the charges, okay? So we're mainly going to look at these like puzzle pieces. When we do form them together, so let's say I'm going to take hydrogen and fluorine, okay? there is that one blank space right here where that one electron can go. So if I were to write, you know, its electron configuration, I would have the 2 dots right here that they are sharing, and I would have fluorine with its remaining dots. Okay, sometimes I will color code these just so that you can see, like, that red one here, that was originally hydrogens. Sorry, that's not a very good red, right? That red there was originally part of hydrogens, and the rest of these were fluorines, and these are the 2 that they are sharing. So this is its covalent bond. This is for the electron dot diagrams. That's how you would draw it. If you're going to draw the structural formula, which is what we're going to be doing today, it's a little bit more simple. We're going to use basically a line that just attaches them. This line represents these 2 electrons right here. We have to also include the lone pairs of electrons, which means there are these here that aren't bonded to anybody else but fluorine. Hydrogen doesn't get any extras. Hydrogen can only take 2 electrons. So this bond right here is all that it can do. I don't need to put any more dots around it. But the other ones, I got to make sure it has, you know, a full number. So if I'm looking at hydrogen, hydrogen has 2 electrons attached to it. It's good. Fluorine has 2, 4, 6, and these 2, 8. So it has 8 electrons attached to it, okay? So this is how our covalent bonding is going to work. And then I talked about some other aspects in the notes with covalent bonds and things like that. All right, give me a second. I gotta find my next thing. Yeah, okay. Back to Zoom. I need to share screen. This. Alrighty. So I posted an assignment that is not for a grade. It is for practice. And I would like everybody to do them just so that I can check to make sure that y'all are doing these correctly, especially those that aren't here. Taylor and Ben, y'all can totally do it with me if you can. If not, you can at least go back, watch it, and do it and show me that you can do it. This is the guidelines for choosing a central atom for the structural formulas, the ones that have the lines. I typically would have this as part of your notes, but since I've posted this as part of the assignment, we'll just keep it there. You don't need to worry about retyping this into the notes. All right. When we do a central atom for a structural formula, we first need to figure out, obviously, what's the one that goes in the middle. That's what we're looking for, the central atom. Hydrogen or fluorine, neither of them can be considered the central atom. Now, the example I gave you with hydrogen and fluorine, they were the only 2, and they just made a nice little straight line. If it's going to make more of a shape to it, we can't put those in the middle. They can only go on the ends, okay? Typically, our central atom usually appears only once in the formula. If there are 2 atoms that could be a central atom, then we look at which one has a lower electronegativity. You can look on page 181 in your books to figure out the electronegativity, or you could go back to what we talked about, or you can pull out that one periodic table that we colored and we did the arrows across to show the electronegativity. Fluorine is the most electronegative, which is one reason it's not in the middle. And then going to the left across a period, those are going to be less electronegative, okay? Going down a group are going to be less electronegative than fluorine, okay? It's going to go across a period first, and then it's going to come down to the next group. Yeah. Well, no, I'll do this later. Okay. So I have 4 practice ones, and I have it so we can draw them straight onto Cami. Typically, I would just have y'all stick these in your notes, but we're going to just do them straight here on Cami because it'll be a little easier. All right, are y'all both with me? Are we good to go?
Yeah.
Yeah.
Okay, all right. If you want to hand draw them, you certainly can, but then stick them on Cami so that I can see it later, since obviously I can't see it right now. That's one reason why I did it this way. But we can just do it straight on here. All right. So we're going to start with this, which is CH4. And I'm going to get into the naming and what these would be called in chapter 9. So I'm not going to give them any particular names. I'm just going to say their symbols and how many there are of them. So this one is CH4. So we'd have to look at. So rule number 1 says hydrogen and fluorine is never central atom. Well, hydrogen can't be the middle. So we know it's got to be the next one. So 2, or B, it says the central atom usually appears only once, and that would be carbon. Yay! So we would then write carbon. You can use, the drawing. You can write a big old C if you want, or you can use the text box. I'm just going to use text box because I'm a little cheaty, I guess. My handwriting looks crappy, so I'm just going to put a big old C there. All right? I'm going to do this in 2 steps, just so that y'all can see. Let me figure out where I want to put this. So I'll put it right here. I'm going to go ahead and put its electron, or the dots. I'm going to make its electron dot diagram so I know what it looks like. And I am going to color code it. I'm going to color code so you can see it. I'm going to fill this so it looks like a nice little dot. So earlier we said carbon was in group 4A, so it has 4 valence electrons. So it's got 1, 2, 3, 4. Okay. Hydrogen is going to have 1 valence electron. So I would have a hydrogen, and I would have only 1 dot off to the side of that hydrogen. I'm going to have 4 hydrogens, and since that hydrogen has 1 dot, I know I'm going to stick 1 here. Sorry, let me give it blue. No, I don't want to make that blue. I want to make that black. I want my dots to be blue. Okay, I'm going to say, that was hydrogens, and now it's sharing it with carbon. I'm going to do another hydrogen right here above, and another dot to represent that was hydrogen's electron that it's now sharing with carbon. Here's my 3rd hydrogen. Dot. That was hydrogens it's sharing with carbon, and then my final hydrogen right here. This is one reason why it really doesn't matter where the electrons are, because they're going to move wherever they need to be to make those bonds, okay? So this would be the electron dot diagram of CH4, but we want to do a structural. So that means we're going to replace all these dots with lines. Wish I could like save all of this. Can I do that? I can't do that, can I? No, I don't think I can do that. I'll redo it. Not that big of a deal. Make a big C, big H, big H, big H, big H. All right, and I'm gonna do lines. I'm gonna draw my lines. I'm gonna make them pink. So I'm gonna have a bond between, ew, that's not thick enough. I need a big thick line. Oops. All right, ooh, yeah, like that. All right, I'm gonna make a bond between a hydrogen there, a bond between a hydrogen there, a bond between a hydrogen there, and a bond between a hydrogen here. Then I'm gonna move my H's. So there's a bond, here's a bond, here's a bond, and then here's my last bond. Okay? Are we both good? Everybody good?
Yeah.
Yeah.
That one's pretty simple. All right, so the next one has phosphorus, which is P, and it has chlorine, and there's 3 chlorines. All right, Taylor, what's gonna be my central atom?
Phosphorus.
Phosphorus, all right? Obviously, I don't have hydrogen or fluorine, so yay. So then I go to B. Central atom usually only appears once. Oh, that's phosphorus, okay? So phosphorus is gonna go in the middle. So I'm gonna start with the dot diagram just so that y'all can see how many electrons it has. And phosphorus was in 5A, so it should have 5 valence electrons. It's gonna be yellow. So we're gonna give it 1, 2, 3, 4, 5. Does not matter where you put them. You can put the 2 on the side if you wanted. Put the 2 on the bottom. Doesn't matter, okay? So we can see there's an opening here for phosphorus to have an electron. There's an opening here for phosphorus to have an electron, and there's an opening here. Yay, because we have 3 chlorines. And those chlorines were in 7A, which means they have 7 valence electrons. Chlorine will have not a very good purple, but we'll do that. Purple, all right? So chlorine had 1, 2, 3, 4, 5, 6. There's its 7th. So here are the 2 that they are going to share. And then I'm going to do that again 2 more times because I have 3 chlorine. So I got to put 1 here and I got to put 1 here. And then I'm going to get my dots once I push the right button. 1, 2, that's the shares. 3, 4, 5, 6. You can make yours more uniform, that's awesome, but I don't really care if you don't, because obviously I'm just kind of doing this again. Those are really close together. Whatever. All right, so this is the electron dot diagram. That's a lot of dots to have to deal with. So make their structural formula. We're basically going to get rid of this here, and this here, and they're just going to be lines. So for the sake of time, I am just going to erase those. And I'm just going to increase, or just put my lines. Where's my shape? No, I want to draw. So here's a bond here, that's 2. Here's a bond here, that's sharing 2. And here's a bond here. I did not delete these because I needed these to show that these are the lone pairs of electrons that are not being shared at the moment. Okay, so when I check it, chlorine should have 8, all right? Hydrogen is the only one that's gonna have 2. Everybody else is trying to get max of 8. So chlorine has 2, 4, 6, this 8 that it's sharing. This chlorine has 2, 4, 6, 8, this is its share. 2, 4, 6, 8 that it's sharing, and phosphorus is 2, 4, 6, 8. Okay? Are we good with that one?
Yeah.
Nobody questions? I don't want to lose anybody.
I'm good.
All right. Now we're gonna get a little trickier. All right, so Ben, let's do 3. Tell me which one's gonna be the central atom. Which one do you think is gonna be the central atom?
Is it carbon?
Okay, so let's look. We know it can't be hydrogen. A said it can't be hydrogen or fluorine.
Yeah.
B says central atom appears only once, while both carbon and oxygen appear once. Darn, which one is literally the central? So then we would have to look at the electronegativities. If we looked on page 181, the electronegativity of carbon is 2.5. The electronegativity of oxygen is 3.5. So carbon is the lower electronegativity, so carbon would be our middle. Yay! So we would put carbon in the middle. Fun fact, in ones like this, the element that is in the middle is a lot of times in the middle when we draw it. That's not always the case, but most of the time it is. All right, so I'm gonna have carbon. I'm gonna do its dots. What color did I use before? I think I used red. I'm gonna stick with red. So I'm gonna do red for carbon's dots. And it had 4. Okay. I'm gonna do the hydrogens next. just because there's 2 and hydrogen each has 1. So I'm gonna just choose where hydrogen goes. It does not matter. Put 1 hydrogen here. And I'm gonna put 1 hydrogen up here. And I'm gonna move it because it's too close to that circle. And hydrogen was blue. I'm gonna put that one there and that one there. Okay. Now we have oxygen. Oxygen was in 6. Make sure I said it right, yep. So it should have 6 valence electrons. I'm gonna put oxygen over here on the side. Oops, no, go away. Come over here, oxygen. Oxygen is going to have a green. All right, so oxygen has, wait a minute. I'm gonna do here. 1, 2, I'm gonna go ahead and pair this one. 3, 4, 5, 6. All right, now, this doesn't look right. Because when I'm looking at this, I have hydrogen. It has 2 dots. That's fine. This hydrogen has 2 dots. This is fine. Carbon has 1, 2, 3, 4, 5, 6, 7. Oxygen has 1, 2, 3, 4, 5, 6, 7. Ooh, this is not good. So I'm gonna have to move something. I'm gonna basically just move and rearrange. Can I move you? Wait a minute, can it just make it bigger? Yeah, okay, I can move it. Move this electron here next to that oxygen, and I'm gonna move, did I move it? No. Oh shoot, carbon, you're in the way. How can I get to that dot? Carbon, you're gonna have to shift just a bit. Okay, crap. Let me grab it better. There we go. I'm gonna move this dot right here. All right, carbon, you can come back down. Ew, go away. Do those selections? Oh shoot, now I have that in the way of oxygen. There, go away. All right. All right, so I wanted y'all to see. I just shifted an electron that was down here by itself. I moved it around so we had a better bond with the oxygen, right? So when I look at this, hydrogen still has 2, this hydrogen has 2, yay. This oxygen has 2, 4, 6, 8, yay! But wait, this carbon has 2, 4, 6. It does not have 8. We're gonna have to move some more electrons. So in the video, we talked about single bonds. So these up here were single bonds. They're sharing 1 pair of electrons, so 2 electrons, okay? Now we've gotten into a double bond. This carbon needs 8 electrons. So oxygen, who is very apt to make a double bond, is gonna have to share a pair of its electrons with this carbon to make a double bond. We're gonna have to shift everybody. I'm gonna move this over here. And for the sake of the fact that I couldn't grab those things, I'm gonna erase all those dots. And I'm gonna make new dots right here. I'm gonna have a double bond. I'm gonna put these back up on top of the oxygen. This is why sometimes drawing it out is best before you write your structural formula and then figure it out. So now when I look at this, I have this hydrogen still has 2. This hydrogen has 2. This carbon has 2, 4, 6, 8. That's for that carbon. This oxygen has 2, 4, 6, 8. Now it's good. Now I need to draw the structural formula, and I'm going to do that below it. I won't delete anything on this one. I have a carbon. I need 2 hydrogens. And I need 1 oxygen. Okay? So I'm going to have an oxygen here. I'm going to put them in the same spots. If you put one below, if you put like the hydrogen up here, the oxygen, or the oxygen up here and the hydrogens on the side, whatever. Excuse me. All right, and then I'm going to draw my line. So I have a bond here. I have a bond here. I have a double bond right here. And then I'm just going to go ahead and put 2 dots for my lone pairs right there. Okay? So that is how this particular one's going to look. Are y'all good?
Yeah.
Yeah.
Sure, Taylor? That sounded a little,
Yeah.
okay. All right. Okay, the last one is there's another part in the notes I talked about what was called a resonance, which means it could be drawn several different ways, the way the bond is going to happen. Like it can bond at this oxygen or this oxygen. And in this case, it's the same thing. We have 2 oxygens, and there's going to be another double bond that's going to form over here. And it doesn't matter which oxygen it bonds with. It could do either oxygen, and it's going to make what's called a resonance image, okay? This, I think, is the only resonance image I'm going to have y'all do, so I'm not going to get into it, you know, a great deal. All right, so when we look at this, we have fluorine, we have nitrogen, we have oxygen. Number 1, or A, said fluorine and hydrogen can't be the central, so it's not fluorine. Number B said it typically appears only once, so that means nitrogen. And nitrogen is going to be our central, so we'll put nitrogen in the middle. I didn't do nitrogen, did I? Need a new color for nitrogen. Nitrogen is going to be brown. Nitrogen was in 5, same with phosphorus. With 2, 2, 1, and 1. Okay? And I'm going to have fluorine. I'm going to do fluorine next. Doesn't matter. You can put fluorine wherever you want. I'm going to put fluorine right here. I'm going to do my shapes. Did I do fluorine? I didn't do fluorine. What color is fluorine going to be? Black. Fluorine can just be black. All right, fluorine is going to have 1, 2, 3, 4, 5. Oh, I missed one right here. 7. I was like, what the heck? 2, 4, 6, and then 7. So it's going to share this bond right here. I have 2 oxygens. I can put 1 here and put 1 here. Okay, oxygen here. Oxygen here. Oxygens each have 6. We're going to have a double bond somewhere. So it really doesn't matter which oxygen we choose to make that double bond with. This one could have the double bond. This one can have the double bond. Let me show y'all why it's a double bond first. All right, so if I had 1, 2, and then I'm gonna have this oxygen there. I don't know why I put that oxygen so far away, but I'll fix it later. Okay, and then I had this oxygen's kind of far away too. Come closer. Oh, I know why, because I was gonna do a double bond, but that's so. I'll just leave it because I'll make that one a double bond. All right, and then okay, this is why we're going to have a double bond. Fluorine has 2, 4, 6, 8, yay. Nitrogen has 2, 4, 6, 8, yay. But this oxygen only has 7. This oxygen only has 7. There's this little lone one right here that's just kind of hanging out. Ooh, that's no good. So we're going to move. I'm going to see if it'll do it this time. Move. I want to move this one here. Now this oxygen has 8, okay? 2, 4, 6, 8. But this oxygen only has 2, 4, 6. Uh-oh, there's still something going on here. So we're gonna have to make a double bond where we get 8 electrons around this oxygen right here. I was about to say nitrogen. What I'm actually gonna do is move these 2 electrons that are here over, and they're gonna bond and make that double bond right here. They could have easily gone down here, and that other lone electron could have come to oxygen. I don't know if I can grab those. I have to move nitrogen down so I can grab them a bit. All right. Oh, shoot, I made it bigger. Grab. No. Where's that? Yeah, there it goes. Okay. So I'll move that one here. Ah, good, I got it that time. I'm gonna move this one here. So I gotta check. Now that I've moved electrons around. This is a little, I guess that's slightly easier than drawing because you really have to erase a bunch of electrons. So fluorine still has 2, 4, 6, 8. Fluorine's good. This oxygen still has 2, 4, 6, 8. That one's good. Okay, so now this oxygen has 2, 4, 6, 8 with that double bond. The nitrogen has 2, 4, 6, 8. Good, everybody has 8, okay? So this is where the resonance comes in. This bond could have been with this oxygen, or it could have been with this oxygen down here. It really doesn't matter which one it was going to bond with, okay? So it could make several shapes. For the sake of, I don't feel like redrawing all the circles, I'm going to erase these, and I'm going to draw my lines for my structural formulas. So I have one bond here, a single bond. I have a single bond here, and I should have 2 double bonds here. And I'm going to check one more time to make sure I've got the correct number of electrons. I have 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Good. All right. So now this is exactly as I need it. There is going to be, I gotta find it, give me a second. I don't think we're doing those 2. Number 7, there's gonna be on a lesson check. Number 7 in the book wants you to draw the electron dot structures for the molecules. They just name it as chlorine, bromine, and iodine, okay? So let me show you, stop share, because I'm gonna stop on that one right now. And I want to go back to my ladybug. Okay, so let me show you that. Oh, wait. All right, so 7, it says draw the electron dot structure for the molecule, and all it says is A, chlorine, B, bromine. I can't read that. There we go. Sorry. And then C, iodine or iodine, however you want to say it. The molecule is Cl2. The molecule would be Br2. And the molecule for this would be I2. So that means you're going to have 2 chlorines bonded together, 2 bromines bonded together, and 2 iodines bonded together. Okay? All of them are going to have 7. So that means they're going to have a single bond, and then they're going to have a bunch of lone pairs. So I'll give you the example of chlorine. So this is one you don't have to do, okay? Chlorine is going to have 7 here. I'm going to color code it. Oh, I forgot. 1. You don't have to color code if you don't want to. I find sometimes it helps people just visualize. This chlorine is also going to have 7. Okay, so this is the pair right here that it's sharing. Since it's saying the dot structures, you can just leave them as dots. You don't have to go and do the lines. If you do the lines, I'll take that too. I'm not going to be that particular with it. Okay, so basically this is what you're doing for number 7. Number 8, it wants you to draw the following molecules, the electron dot structure. If you want to do the formula structure with the lines, you can do that also. There's just 2 for you to do. You just got to figure out which one's the central atom and then put the other ones around it. I don't think we're doing 9 and 10. I think I got rid of those. And I got to look to see if the other ones. And then I think you're going to do 3 more on number 20. You're going to do the electron dot structures is what it says. But if you want to do the structural formulas with the lines, you may. That's fine. So that's in the lesson check. But then I give you 6 or 7 other ones on Kami to do for grade. So these were just for, the ones we did today were just for practice. So I will check over y'all's when you submit it, and hopefully everybody else, when they submit it, I will check over them and then let y'all know if y'all are good. Tomorrow, the other ones for you to do, I think it's 6, it might be 7. But I have it on Kami, and I went ahead and just added the rest of the lesson check on Kami. You can just do the text box and then just type your answers for the ones that are words. And then the ones where you're drawing these, you can just do them straight on the Kami document, okay, and turn it in. If for whatever reason all of that bothers you and you want to do it on paper, that is perfectly fine. Scan it to me and send it to me, okay? Anybody got questions?
No.
Can you go back to the last question? I didn't get to copy it.
Which one?
The number 4. Like, I think I could put it down, but I'm not sure.
This one right here?
Yeah.
Okay. Yeah, this is what it looks like. I'll
Okay.
leave that up for you. And I will be available tomorrow. Send me an email, send me a message. Miss Sexton, I'm lost. I will jump on either a Google Meet or a Zoom with you and walk you through anything. So just let me know. We're supposed to be here at school from like 8:30 until at least 12:30. I'm here most of the time a little bit later than that. I will have my girls with me. So they may want to come over and say, hey, if y'all want help, but I will, of course, be here Thursday and I will be here Friday. So just let me know if y'all need assistance. And then maybe I'll see y'all next week, I hope. Okay? All right, Taylor, you got that?
Yeah.
All right, Dan, you're good?
Yeah.
Okay, I think we are done. I will post this video for anybody else or if y'all need to go back and rewatch it, okay?
Okay.
All right, I'll see y'all later.